Problem number 18 requires us to find the voltage at different points on our grid. The voltage is given to us as 6,000 Newton coulombs directed to the right. We can find the voltage at different points using the equation E equals dV dx. Knowing that E equals 6,000, we can set E equal to 6,000. The distance from A to point E on the grid is 0.2 centimeters. So to find the voltage, the change in voltage, 0.2 centimeters away, we plug in 0.2 for dx. This gives us the voltage is equal to 120 volts per 2 centimeters, or a change in 60 volts per centimeter. They give us that A is 40 volts. Point E is 2 centimeters from A, so the change in voltage would be 120 volts. At E, the voltage would be 40 volts, which is the voltage from point A, plus a change in voltage over 2 centimeters, which would give us 160 volts. It is positive because E is located to the left of A, and the electric field is pointing to the right, which means that in the direction of the electric field is lower voltage, while to the left it will be a higher voltage, so E is higher voltage than A. At B, B is 1 centimeter from A, so the change in voltage will be 60 volts. So at B, the voltage will be 40 volts minus 60 volts, giving us negative 20 volts. At C, it is 2 centimeters from A, so the change in voltage will be 120 volts. And at C, the voltage will be 40 volts minus 120, giving us negative 80 volts. At D, it is 3 centimeters from A, so the change in voltage will be 180 volts. At D, the voltage will be 40 volts minus 180 volts, giving us negative 140 volts. In order to find the voltage at point D, given the electric field 3 times 10 to the negative third times x to the negative third in the I direction, plus a y component, we only have to worry about the x component because D and A are on the same axes. They're both located on the x axis, so there will be no y component of the electric field. So with that being said, the change in voltage will be equal to the integral of E dx, which would be the electric field in the x, which is 3 times 10 to the negative third times x to the negative third. So we just integrate that and we will get, this is a constant, so we pull it out and then we integrate that x to the negative third, giving us negative x to the negative 2 over 2, and we evaluate it from 0.01 to 0.04 because that is the interval distance between A and D. So we just plug in our numbers for this integration to solve for these two. So we plug in 0.04, we plug in 0.01, and we get that the change in voltage is equal to 14.06. So with that being said, the voltage at D is 40 volts minus 14.06 volts, giving us 25.94 volts.